Hello, today we're going to talk about Chapter 3, Lesson 1. You'll find that on pages 171 to 178. Let's get started. Today's lesson is on linear relationships. Linear just means that a relationship is a straight line if we graph it, okay, and that there's a constant rate of change between any 2 points. So as far as the graph goes, it looks something like this, where it has the exact same slope throughout the graph. All right, so one way you'll identify whether something is linear is looking at the graph. Another way you will look at something that's linear is, because you don't always want to have to graph something, like if they give you a graph, it's very easy to tell if it's linear. But sometimes they give you a table, and you're going to want to look at the change in y. So how does y change throughout? And in this case, it's changing. It's adding by 2 every single time. And then over the change in x. So again, it's changing at a constant rate, 2 over 1, or 2 songs per 1 minute. So we can check this way, and if these results, this division is the same every time, then we have a linear relationship. So if you graph this, it would look just like this. Okay, so that's the first thing we have to do. Is the relationship linear? You'll look at a graph, you'll look at a table, you'll say yes or no. Now, if the graph is curvy or doesn't have a constant rate, maybe it jumps at some point, then you would say no, it's not linear. And if you're checking a table and you see these numbers aren't giving you the same ratio every time, the change in y over change in x is the same every time, then you would say no. So here are a couple examples I want you to try. Take a look, so pause the video and then we'll go over it. All right, so table first. So change in time this is the x column, this is the y column. Okay, and let me get my pen out here. If I go from 95 to 90, that is a decrease of 5. Okay, 90 to 86, that is a decrease of 4, and 86 to 82 is also a decrease of 4. So I'm probably going to have to say no here unless these intervals are different, but I can tell right away they're not different. This is an increase of 5, and you can see the rest of the way these are also increases of 5. So because the change in y over change in x is not constant, we go from -5 to -4 to -4, and all these are the same, then this is not linear. So this is not linear. Now this one to me looks linear. I'm going to it looks like a straight line. I see in this case down 20, so each of these are worth 10. Down 20, forward 8, down 20, forward 8. So this is linear, and you can pretty much tell that's a straight line. At least that's supposed to be a straight line. Sorry about that. So this is a linear relationship. All right, let's take a look at our next example. Proportional linear relationship. So in this example, example 2, not only are you going to have to determine whether the relationship is linear, we're going to check to see if it's proportional. Okay? And essentially what this box is telling us is that if we take our output and divide it by our input, each individual output and input should be the same throughout the problem. Okay, then it is also proportional. Not only is it linear, it's also proportional. So we're going to check for linear and then proportional. So again, you're going to divide b over a. And to looking at a graph, if you want to know if something's proportional, it goes through the origin. So I'm going to kind of do a little quick. So if we had a graph and you had a line, let's make it green. If that line went through the origin, it would be proportional. So that's a really quick check. If it goes to the origin, the 0, 0 point, it's proportional. If it doesn't, then it's not proportional. Okay, so we'll have 2 ways to check this as well. All right, so first we're going to check to see if it's linear. Okay, So check for a linear relationship, check for a constant rate of change. So we're going to looking for how these change. And these change by adding 9.8 every single time. So the speed has a constant rate of change, and you can see the time also has a constant rate of change. We're increasing by 1 every time. All right. So yes, it's linear. And then what we want to do is we want to divide this speed by time. 9.8 divided by 1 is 9.8. All right. So to check for proportionality, y over x. Y over x. So it's going to look, we're going to divide every one of these. And when we do, every single one of these does equal 9.8. Okay. So this is also proportional. All right. And it kind of gives it away right here. It gives us the 0 point. It is a value, so that also tells us it's proportional. All right. Now, I want you to pause this video and give this a shot, and we'll go over this one in class. All right, so if you stuck around, here's how this works. So I am looking at this degrees in Celsius, so 0, 5, 10, 15, 20. So that is increasing by 5 every time. Hope you can see that throughout. And the bottom here is increasing by, let's see, 8, 9, and then 9 and 9. So it is linear, okay? This is increasing by 9 every time. So it is linear. However, it is not, I can tell you right now, it is not proportional because this first point, 0, 32, is not 0, 0. So it does not go through the origin. All right, it goes through at kind of like that. All right. But again, if we wanted to check mathematically, we could say 0 over 32 is 0. 5 over 41 is not 0. So this relationship, the division between A over B or B over A, is not the same throughout. So this is not proportional. So there's a couple ways. You can look at this first box. That's not 0, 0. It's 0 something else. They don't always give you 0, 0. And these divisions are not the same. 5 over 41 is not the same as 10 over 50 or 15 over 59. So not proportional. Hope this video helps, and we'll see you guys next time.